Hello students and welcome to the lecture. So students, as we know that in the previous lecture we had started our discussion over the Newton's laws of motion, and that was our part 1. In this we are going to talk about the Newton's laws of motion. This is going to be our part 2. In the previous one we had talked about the Newton's 3 laws of motion and the application of impulsive force. In this lecture we are going to talk about the fundamental forces in nature, and at last we will see the summary of all of this. I hope you have revised the previous lecture in the well enough manner. Before you have come for this lecture, as many times I have told you, it is for your own benefit. Okay. Before starting this lecture, there is a small disclaimer presented over here. The disclaimer is like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, let's begin with the fundamental forces in nature. So basically at present stage of our understanding physics, because if you remember when we had started the discussion over the units and dimensions and when we were discussing about the science, I had told you one thing. Science is not static, it's dynamic. Okay, so far whatever we have found in science, it is not that these things are absolute. These things might be changes over the period of time. Maybe we had only found 10% of the scientific facts. Anything could be happened because we have no specific data. We only believe on the scientific facts which are proven in nature so far. Okay, so that's why you can say at present stage, as of our understanding physics, it has revealed that all the forces occurring in different contexts arise from a smaller number of fundamental forces in nature. Like whatever forces you are seeing around yourself in the scientific manner, these all forces arising because of the small number of fundamental forces in nature. So, the origin of drive forces is complex, yet they could be understood in terms of following four fundamental forces, which govern the macroscopic as well as microscopic world. Like these are the fundamental, or you can say these are the absolute forces. So far, whatever we had found on the basis of this, the conclusion that we have drawn, we could say these forces are fundamental forces. All other forces are drive forces, and because of these forces having the capability to govern the macroscopic world as well as the microscopic world. Okay. First, gravitational force as a fundamental. Second, weak nuclear force as a fundamental. Electromagnetic force as a fundamental. Strong nuclear force as a fundamental. Here you can also see gravitational force, electromagnetism force, strong nuclear force, weak nuclear force. Okay. So these four forces are the fundamental forces in the nature. All other forces that we see, those forces are derived from these fundamental forces only. If we talk about the first force, this is the gravitational force. The gravitational force is the force of mutual attraction between any two bodies by virtue of their masses. Like you can say if there are two bodies, okay, then these bodies will have a attraction on each other. That is what we call as a mutual attraction. And this attraction is happening by virtue of their masses. And whenever the mass of a body exerts a force of attraction on another body, then it is known as the gravitational force. The magnitude of the force exerted by a particle of mass m1 on another particle of mass m2 at a distance r from it is given by Newton's law of gravitation. It will be force equal to gm1 into m2 by r square. Okay, this is an important formula. Here you can also see this in this picture. This line that you are seeing, it is the earth surface. What is earth? Earth is also the body. The ball that you can see over here, that ball is also a body. So you have noticed it, whenever you throw a ball in the upside direction, you will notice the ball will come to the earth or come down to the earth. Why it is happening? Why? Why the ball not maintaining its position being upside? Why it is coming down? Because both the ball and the earth exerting a force on each other. That force is a mutual force of attraction, or in short we could say gravitational force. Okay, and it is by virtue of their masses, because the earth mass is much higher than the ball mass. So the ball's mutual attraction will be lesser in comparison with the earth. So ball will come down to the earth instead of earth will attract to the ball. Okay, where g, if we go by the formula, g is the universal gravitational constant, having the value g is equal to 6.67 into 10's power minus 11 Newton meter square or kilogram square. The direction of the force on M2 it's towards M1. An equal but opposite force is existed by mass M2 on mass M1 in accordance with the Newton's third law of motion. Because as we had discussed in the previous lecture, whenever the force applies, the force never applies singular. Okay, like you can say if you punch the wall, okay, with your hand, by using your hand you have exerted a force on the wall. So you are not the only one who is exerting a force on the wall. The ball will also impact the same amount of force on your hand. Okay, so this is also written down here. If the m1 applying a force on m2, the m2 will apply the same but opposite force on m1 in accordance with the Newton's third law of motion. Thus, the two particles exert equal forces of attraction on each other. Like here you can say, this is moon, this is earth. Okay, so if the earth applying the force of attraction on moon, the moon will also applying a force of attraction on the earth, which is equal but opposite. Okay, like earth is trying to pull the moon in its side, and the moon will trying to pull the earth on its side, but the amount will be same, direction will be opposite. Some of the important features, properties of gravitational forces are, if we discuss them. First, gravitational forces are universal attractive forces. Okay, therefore they exist between the microscopic as well as the macroscopic objects irrespective of their size, shape, separation and intervening medium. So remember, gravitational force is a universal force. It is not introducible force. It is already there. It is universally available. It is existed in both microscopic and macroscopic objects. Okay, and it is irrespective of the size of the object, the shape of the objects, the separation and intervening medium. It is only depend on the mass. Apart from mass, it is not dependent on any other. These forces are never repulsive. Repulsive means, suppose now you can say these are the two particles. They both will try to get each other on their side. It is attractive force. They will not try to push each other from their side, so that they could never be a repulsive force. Okay, in attractive force they will try to pull each other on their side. In terms of repulsive force, they will try to push each other away from their side. These are the weakest force in nature. Okay, They operate over very long distances, especially when the objects are massive. Like here you can say, if this is the earth, this is the moon, this is the sun. So they all will applying a force of attraction on each other. Okay, but that force of attraction is applying from a very long distances. The earth is not very closely situated in comparison with the sun or in respect to the sun. Similarly, the moon is more than 3 lakh kilometers away from the earth. It is not like the moon is only 1 kilometer, 2 kilometers away from the earth. Okay, for example, rotation of earth around the sun is due to the gravitational pull of sun on earth. Like the sun trying to attract the earth on its side. Okay, earth is existing the same force in the opposite direction on sun. That's why they having the revolution or rotation, you can say. Basically, you can also see the earth is trying to attract the moon on itself. The moon is trying to attract the earth on itself. So that's why the moon is rotating around the earth. Okay, gravitational forces obey the inverse square law. Therefore, they vary inversely as the square of distance between two bodies. Like you can say, if the square of distance between two forces becomes higher, the gravitational force becomes lower. If the distance or the square of distances between the two bodies lesser, the gravitational force will be higher. Okay, so it's depend on the square of distance between two bodies, but inversely. The higher the distance, lower will be the force. The lower the difference, the higher will be the force. Gravitational force are central forces because they operate from the center of an object. Therefore, they act along the line joining the centers of two bodies. Like here you can say, in earth, at center we have the core. So the core of the earth applies the attraction force on the moon. Similarly, the moon center applying the force on the earth. Okay, gravitational force are conservative forces. They conserve within the body. They are not required to be generative. The field particle of gravitational force is called graviton. The concept of exchange of field particles between two bodies explains the law two bodies interact from a distance. So if you want to get the explanation of interaction between two bodies from a distance, you need to understanding the concept of exchange of field particles between two bodies. Now, second is weak nuclear force. The weak nuclear force appear only in certain nuclear processes such as the uh, beta decay of nucleus. Okay, in beta decay the nucleus emits an electron and an uncharged particles called neutrino. These are the neutral particles. Uncharged means they are neither positive nor negative. They are neutral or uncharged. The weak nuclear force is not as weak as the gravitational forces, but much weaker than the strong nuclear and electromagnetic forces. Okay, the range of weak nuclear force is exceedingly small, of the order of 10 power minus 16 meter. The weak nuclear forces are 10 power 25 times stronger than the gravitational force. Okay, electromagnetic force is the third fundamental force. The electromagnetic forces are the forces between the charged particles. Okay, what are the charged particles? So charged particles are of two types: negatively charged and positively charged. Okay, so basically electromagnetic force is the force that applies or that basically works between the charged particles. If the particles are not charged, you can say these particles are neither positive nor negative. Electromagnetic force will be not there. If the particles are charged, whether positively or negatively, then the electromagnetic force would be in the picture. When the charges are at rest, the forces are called electrostatic forces because they are having the charge, but because they are not moving, they are static, so that's why electrostatic forces. The forces between unlike charges are attractive and the forces between charged are repulsive. So you can say, now here you can say they are the two pictures that explaining it well. Like in the gravitational forces, we have come to know about the gravitational forces are attractive forces. They are not repulsive forces. Okay, because in the gravitational, both bodies trying to pull each other on their side. In electromagnetic, the forces attractive and repulsive. Why? When the charges of particle are different or unlike, the force would be attractive. When the charge on particles like or the same, the forces would be repulsive. How it works? Now here you can say one particle having a negative charge, one particle having a positive charge. Here you can say the arrow are towards each other. So this is the attractive force. This is the force of attraction. Okay. If you look at this picture, this is the negative, this is also negative. Here you can say instead of together or towards each other, the arrows are on the opposite side. So the force is repulsive. Alright. So what we have drawn a conclusion from here, charges are same, electromagnetic force will be repulsive. Charges are different or unlike charges, the electromagnetic force will be attractive. Okay. The force is governed by the Coulomb's law. The charges in motion produce the magnetic effects on a magnetic field, give rise to a force on a moving charge. Okay. So like you can say when there are the charges which are in the motion, so these charges will generate a magnetic effect on the magnetic force to give a force on a moving charge. That is why electricity and magnetic forces in general are inseparable. So whenever there is a magnetism, electricity would be there. Whenever there is electricity, the magnetism would be there. These are inseparable. Why? Because in electricity, the charge is in the motion. And when the charge is in the motion, automatically they will generate a magnetic effect. Hence the name electromagnetic force is defined. It comprises the electricity as well as the magnetic. The magnitude of electrostatic force F between two static point charges Q1 and Q2 separated by distance r in air vacuum is given by the Coulomb's law. Like F is equal to this formula, where this is 9 to 10 power 9 Newton meters cube by c square constant, and it is 8.85 into 10 power minus 2 C2 nm minus 2. It's an absolute electrical permittivity of free space. Electromagnetic forces is much stronger than the gravitational force. It dominates all phenomena on atomic and nuclear scale. The structure of atoms and molecules, the dynamics of chemical reaction, etc., governed by the electromagnetic forces. Some of the macroscopic forces, like the forces between two surfaces in contact, force of friction, tension in spring/rope, forces due to spring, etc. These also explained in terms of the electromagnetic forces. The smallest magnitude of charge found in nature is the charge on an electron minus e or a proton positive e, represented is equal to 1.6 into 10 power minus 19 c. All charges are found to have magnitude n, where n is an integer. Electric charges therefore said to be quantized. Some of the salient features of electromagnetic forces are, if we try to talk about them, these forces may be attractive or repulsive, like we had just seen. Whenever the charges are unlike to each other. One is positive, another one is negative. They always have the attractive force whenever the charges are similar. Okay, one particle is positive, another particle is also positive. One particle is negative, another particle is also negative. The charge is same, then there will always be a repulsion. Like charges repel each other and unlike charges attract each other. These forces governed by the Coulomb's law, which are similar to the Newton's law of gravitation. They obey inverse square law. Electrostatic forces between two protons are 10 power 36 times stronger than gravitational forces. They operate over distances which are not very large. They are central forces. They are also conservative forces. They are conserved. The field particle of electromagnetic force is photon, which carries no charge and has zero rest mass. Now the strong nuclear force, the last fundamental force in nature. The force that bind the neutrons and protons together in nucleus are called the strong nuclear force. Okay, binds the neutrons and the protons. Neutrons are neutral, protons are the positive charged particles. In the nucleus of an atom, neutrons and protons are present. So the force that having the capability to bind these two between in the center of the nucleus, this force is called the strong nuclear force. They act between two protons or two neutrons or a proton and a neutron, but only if the particles are very close to each other, because they couldn't operate on the large distance. When two nucleons are within the 1 Fermi or 10 power minus 15 meter of each other, the strong nuclear attractive force is about 10 times stronger than the repulsive electric force between two protons at this separation. This is why a nucleus is a stable structure in spite of strong electrostatic forces of repulsion between the protons. Nuclear forces come into picture only if we consider charges within the nucleus. Okay, because if it's neutral, nuclear forces couldn't be in the picture. But if we try to consider the charges within the nucleus, the nuclear force will be in the picture. Some of the salient features of the nuclear forces are: first, nuclear forces are the strongest forces in nature. Second, they are 10 power 38 times stronger than the gravitational force, 10 power 2 times stronger than the electrostatic force, and 10 power 13 times stronger than the weak forces. Nuclear forces have the shortest range, okay, because they operate between inside the nucleus of the atom only. Okay, so they're having the shortest range. They operate within the nucleus only. That is what I have told you right now. Nuclear forces do not depend on charge on the nucleon. They are basically attractive forces because the neutron and proton both are having a different charges. Nuclear forces do not obey the inverse square law. Nuclear forces are non-central forces. They are also non-conservative forces. The field particle for nuclear forces is the pi meson. The relative strength of four types of basic forces in nature could be presented as this one, which means force gravitational, force weak nuclear force, force electrostatic force, or force nuclear force. 1 ratio 10 power 25, 10 power 36 ratio 10 power 38. Now, fundamental force in nature, if we talk about gravitational force, relative strength 1, range infinite, operations, all object in nature, presenting in all object of nature. There, weak nuclear force, relative strength 10 power 25, range, some nuclear size, availability, some elementary particles only. Electromagnetic force 10 power 36 is the relative strength, range not very large, charged particle. Strong nuclear force 10 power 38 relative strength, nuclear size is the range, opposite to the nucleons. Here we have finished the topic. Now it's part for the summary discussion. We had talked about the physics, identification of four fundamental forces that govern both the macroscopic and macroscopic worlds like gravitational force, weak nuclear force, electromagnetic, and strong nuclear forces. Gravitational forces we have discussed. These are universal attractive forces between any two masses defined by the Newton's law of gravitation. Weakest force in the nature but operate over very large or long distances. Central conservative obeying the inverse square law. Field particle is the graviton. We have talked about the weak nuclear forces like appearance in certain nuclear processes like beta decay where a nuclear emits an electron and neutrino. They are the stronger than the gravitational forces but weaker than the strong nuclear and electromagnetic force with a very short range of about 10's power minus 16 meters. They are 10's power 25 times stronger than gravitational forces. We have talked about the electromagnetic forces. These forces act between charged particles. When charges are at rest, they are called electrostatic forces governed by Coulomb's law. Electromagnetic forces are much stronger than the gravitational forces, dominate atomic and nuclear scales. They could be attractive or repulsive, obey the inverse square law, and concentral and conservative. Field particle is the photon. The strong nuclear forces we have talked about bind protons and neutrons in a nucleus and the strongest force is nature. 10's power 38 times stronger than gravitational forces. Operate over very short distances about 10's power minus 15 meters. Do not obey the inverse square law. Non-central and non-conservative with the field particle being the Pymeson. The relative strength of these forces are gravitational force 1, weak nuclear 10's power 25, electromagnetic 10's power 38, strong nucleus 10's power 38. Okay. With this, we have finished this lecture. It is requested to all of you kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.